Good morning, guys. Today's lesson will be about parent functions, and this will be part one of this topic. And just a reminder, you know, especially if you don't have a way of printing out the notes, make sure that you, you buy or obtain, a graphene notebook. That way, it has a sort of grid so that you can kind of graph a little bit more easily, especially when doing the Mastery Connect assignments, because um, we're going to ask you guys to show us the graphs that you came up with, and so that it looks neater and nicer. If you have a graphene notebook with graph paper, um, the graphs will come out nicer in that format. So make sure that you have something to graph with, especially for the Mastery Connect. So, uh, so we're going to talk about parent functions and look at some key properties concerning those functions. Um, Parent functions. So the reason it's called a parent, uh, you know, is because it has, I want to call them children, but they're functions that belong to the same family. And so we're going to look at what characteristics is the main parent uh, composed of, right? What features, what properties does it have? And the first parent function we're going to look at is the constant function. And some people call it constant. You can also call it, a horizontal line. But the reason it's called constant, right, is because it stays at a constant level, right? Horizontal, it doesn't increase or decrease. It stays constant. And so one of the things that it has, and actually there should be arrows going to the left and to the right. So let me put an arrow there. And so one of the properties that it has is that it doesn't matter what x is. X can be any number, but it's going to have the same y value. So for example, if x equals 1, the y value is 2. If x equals 4, the y value is 2. If x equals -5, the y value is 2. So in this example, all the y values equal 2, but for now we're going to call the y value a, because for different problems this value might change. So we're just going to call it a. And so on the table here, I'm going to put, if x equals 0 and 1, so it doesn't matter what x's I choose, my y value is going to stay constant or the same. Okay. The domain of a constant function also does not change. And so domain, remember, is going from left to right. So let me pull out the same tool that I used when we talked about domain and range. So if I go from left to right, on the left side it's going towards -infinity. And then as I move to the right, I'm still hitting the graph, and there's an arrow on the right that goes towards +infinity. And then we would look at the range, which is going from bottom to top. And so we would use a different tool for that, going from bottom to top. And so as I'm going from the bottom to the top, when do I actually make contact with the graph? In this case, I make contact at 2. But for in general, right, whatever a is going to be, because remember a changes. In this case, a is equal to 2, but different examples are going to give different problems. So I want to give a general range answer. So the answer for the range is going to be the value of A. And we usually put a curly bracket around it to say that it's one value. Okay. Yeah, so that's for the constant function. Let's look at the next parent function on the next page. So the next one we're looking at is the linear parent function. So linear meaning from a line, right? And we've seen this also. Again, this will have arrows. And looking at the table, let's kind of zoom out here. It has two constant points, which one is the very center, which is 0, 0, 0, 0, and then the other point to make it the parent function is 1, 1. The domain of this function, it's going from left to right. It has an arrow, so it's going towards negative infinity on the left, and as I go towards the right, there's an arrow that keeps going to the right towards positive infinity. So let me show you again with the tool, vertical tool. So as I'm going towards the left, it's in negative infinity, and then as I go towards the right, it's positive infinity. And then the range is going from bottom to top. So as I'm here at the bottom, I have a negative infinity, and as I go to the top, there's a positive infinity. Okay, and then there's two forms. One that we've seen already is we've seen these two actually. If you remember at the beginning of the course, beginning of the year, there was slope-intercept, where m is the slope and b is the y-intercept. So just want to remind you guys again, m is the slope and b is the y-intercept. And then we saw a point slope form, where again m is the slope and y1 and x1 is the point. Right. And so let's look at some examples to kind of get the feel of things. Delete this. And so example 1. And so as we're working on these examples, we want to identify the parent type and the equation. And so the parent type is, in this case, the constant. Okay, because if we look at it, it's f of x equals a number. It doesn't have any x after it, so it's a constant function. The equation of the constant function is again on the first page, but it's f of x equals a. Okay, and then we chose x values, 0, 1, and the y value doesn't change, but it remains the same. In this case, the y value is going to be -3. So both y values are negative 3. And so the graph is gonna, if I plot these two points here, 0, negative 3 would be right here. I'm gonna use purple. And then 1, negative 3 is right here. And so if I connect these 2 points, I would get, a horizontal line. And so what's the domain? Remember, domain is going from left to right, and this line is going towards the left towards negative infinity, and towards the right towards positive infinity. And then the range is, well, it's not going up or down, it's staying constant, and it's constantly the value of negative 3. Right? It's a constant negative 3. So the range is going to be a curly bracket 3. Okay. All right. Let's look at example 2. All right. If we look at the function, it's not equal to a number, right? There's an x in there. So because there's an x, and it's x to the power of 1, it is a linear function. The parent function or parent equation is actually on this page, and this is the equation. So f of x equals x is the parent equation. Okay, and then we're going to graph this, but remember we have to identify a couple of things. For example, in front of the x there's a negative 1, and it looks like it has the form of y equals mx plus b. So in this case, m is the number in front of x, so the number in front of x is negative 1, and b is 7. Okay, so that just means that the slope is negative 1 and the y-intercept is 7. If the slope is negative 1, remember there's a 1 underneath. Actually, you know what I'm just going to write it in black. So slope is negative 1, y-intercept is 7. Remember, if I want to make the slope into a fraction and there's no number underneath, we assume that there's a 1 underneath. And so the slope is rise over run. So the top number, the negative 1, tells you to go down 1. And the positive 1 tells you to go to the right 1. So we're going to graph the y-intercept first. And actually, let me write it out again. So this is the y-intercept. And so that's going to be at 7. And then the slope tells me to go down one to the right one, so that would go here. Then I would connect these 2 points. Like this. Okay. And so that would be my line. And then we would ask ourselves, what's the domain and the range? And so I use a blue line. So if I look at the domain, that's going from left to right. So it has an arrow, so it's going to the left towards negative infinity and to the right towards positive infinity. So that's for the domain, going from negative infinity to positive infinity. And then the range is going from bottom to top. So as I'm coming towards the bottom, towards the graph, as I'm approaching it, there's an arrow there. So that arrow means that it keeps going towards the bottom and towards negative infinity, and then it keeps going towards the top, towards positive infinity. So I'm going to put negative infinity to positive infinity. Right, and so there's my line. This is the parent type. This is the equation, and the domain and the range. And I had to figure out what the slope and the y-intercept were. Okay, and let's do one more. This has the format of, actually it's right here, the point slope form, and so that's in the category of linear. So at least we know that the parent type is linear, and the parent equation is f of x equals x. Okay, and so we're going to identify, well, if it's in the form y minus y1 equals m x minus x1, then we should know that the m is the slope, and so in this case, this 1/3 is the slope. And since it's 1/3, it means that it wants you to go up 1, and to the right 3. Okay. The other thing we have to identify is the point. But remember, we're going to think of collecting these, which correspond to +2 and +4, where we're going to think opposite. And what I mean by opposite, if it's positive, we're going to think negative. If it's negative, we're going to think positive. So the point that we're looking to find is going to be, it's usually x comma y. And so we're going to use 2 and 4. 4 is going to be our x and 2 is going to be our y, but remember the opposite of a positive 4 is negative 4. The opposite of a positive 2 is a negative 2. Okay. So I'm going to plot this point first. And I'm going to graph it here, but I'm going to use blue because I already used purple. Unless I choose a different color. Let me choose a different one. I'll just choose green. Okay, so I'm going to graph the first point, -4, -2. negative 4 is 1, 2, 3, 4, and negative 2, 1, 2. So right here is going to be my first point. Right there. All right, so let's check it again. We're going to go 1, 2, 3, 4, 1, 2. And again, if you have a graph paper, you'll have this grid, and so it'll make graphing, a whole lot easier. Especially if you don't have a printer, then make sure you go out and get some graphing paper or a graphing notebook. Okay, and then the slope is telling me to go up 1 and to the right 3. So I'm going to go up 1 to the right 3. Should be right here. Let's check it. Up 1 to the right, 1, 2, 3. Yes. And so using my ruler, making sure I can connect this. Let me see if I got. It's a little bit crooked, but there we go. And then what's the domain and range of this? So domain is going from left to right. So as I'm going towards the left, there's an arrow which is going towards the left towards negative infinity. And as I go towards the right, it's going towards positive infinity. And then the range is going from bottom to top. So as I'm approaching the line from the bottom, there's an arrow, and that arrow is going towards negative infinity. So negative infinity to up towards how high is the graph going? It's going towards positive infinity. So my range is negative infinity to positive infinity. All right. Well, thank you for joining me today, guys. Again, feel free to ask me any questions in class. That way we can get those questions answered and clarify anything that may be unclear or you may be confused about. But I'll see you guys in class, and have a great remainder of your day.